This section is section 6.3c, which is rationalizing denominators. Okay. Yikes. Did not write that very well, did I? We have 36, the square root of 36ab over the square root of 9ab. Which we could, if we wanted to, since the indexes are the same, we could write them as one fraction on the inside. And we could cancel where we could. So we know that b's would cancel, the a's would cancel. And 9 goes into 36 4 times, which gives us the square root of 4. And when you take the square root of 4, you get 2. So that would be our answer. They usually look more complex than they really are. So this one here, we didn't have to rationalize the denominator. Let's try this one. We've got the square root of 23c cubed divided by c. So they're both square roots, so we could cancel where we can, which that causes us to have the square root of 23c squared over, and we cancel that, so we have the square root of 1, which is just 1. And since 23 is a prime number, so we're not going to be able to pull the 23 out, but we have a pair of c's, so we have c square root of 23 would be our answer for this one. Now let's do another one. Maybe this one will have one that we can rationalize. Square root of 35 over the square root of 14. If you look at those, you can identify that they have a 7 in common. So if we divide by 7 on each one of these, we're going to get the square root of 5 over the square root of 2. Since this one we are going to have to rationalize on, because we can't get rid of this on the bottom, and rationalizing means we get rid of the rational expression that's on in the denominator. I apologize for my stuttering. So since we need, the index is 2, we know we need 2 2's in order to pull out a 2. So we're going to multiply this by the square root of 2. And since we don't really want to change the value, we can multiply by 1. And the square root of 2 over square root of 2 really is 1. So it won't change the value. So now when we multiply these two fractions, we multiply the top. So we're going to get the square root of 10 over, and then we have 2 2's at the bottom, which pull out a 2. Now, this is where I need to remind you that, remember, these are very picky. They're borders. They're segregating these things. Anything on the inside cannot mix with something that's on the outside. Even though there's a 2 in common between the two of these, if you were to put the answer as the square root of 5, that would be wrong. Okay? Because 2 is on the outside here, and there's a 1 over here that's outside. If you were to reduce, you have to reduce on the outside only and on the inside only. So this particular one, that's your answer. Okay. Let's try a new one. We have the cubed root of 54 divided by the cubed root of 10. Since both of these are the same, has the same indexes, we could write it as one fraction, so we can, and they're both inside, so we can divide by something they have in common, and they just happen to have a 2 in common. So let's divide each one of those by 2. The top one would now be the cubed root of 27 over the cubed root of 5. Since this is kind of interesting because we need, the index says we need 3 of these. So we're going to have to multiply by enough so that we have no more radical. We need 3 5s in order to pull one out. So we have to multiply twice. And this gives us the cube root of 27, I just happen to know is 3, because 3 times 3 is 9, and 9 times 3 is 27. So I'm going to pull out a 3 here. But since we don't have, there's still just 2 of these on the top, we have to leave them inside. Now we have 3 5s on the bottom that we can pull out a 5. And of course I forgot to run my little 3 here, which would make it wrong. Okay, and that would be our answer. Let's try, we have the cubed root of 6 divided by the cubed root of 75. They're both the same root, so we could reduce if we wanted to, and they do have a 3 in common. So this gives us a new of the cubed root of 2 over, what would that be? 25. 25. The cubed root of 3. Now, to make this easier, we could identify that as 5 times 5. So all we really would need to do is multiply by the cube root of another 5 to get a third 5. You can do that, or you could just multiply it all by 25. That's just going to be more math to do. So this one, and you'll see here, I'm going to do both of them so you can see that they're both the same. The cube root of 5 over 25 times the cube root of 25. I don't like these markers. Okay. So we get here, we get, what would that be? Two times 50. No. We would have to multiply by 3. Oops. To get 25 on the bottom. And this one here, since there's 2 here, which we need 3 of them. It gives us 2 times 25 times 25 is 1,250. And if you take 1,250 and start dividing it out, you get 250 by 5, which is 50, by 5, which is 10, which is 5 and 2. And we need 3 of them, so we could pull out a 5, square root of 10 over 25, and then you'd have to reduce, which will give you 5. Well, that was a long, hard way, and if you had recognized up here like I showed you, that 25 is actually 2 times 2, and since we need 3, we could have multiplied by just one more 5, which would have given us a 5 on the bottom. And then 2 times 5 is 10, and it's all in a cubed root. And as you can see, whoops, I forgot my cube root down here on the bottom. These two, this one, and the one down here are exactly the same. So that one was kind of hard when you looked at it. If you can recognize the smaller numbers and not have to multiply them out, it's a lot easier. Now, I want to introduce you to a term that's called the conjugate. And whenever, for instance, we have this problem right here. -3 divided by, before we were just working with one term in the bottom. See? There's just one term in the bottom. And now we're going to work with where there's 2 terms in the denominator. And when you have 2 terms, you want to do what is called multiply something by its conjugate. And the conjugate of something is just the same thing with this middle sign changed. So the conjugate of the square root of 3 minus the square root of 6 is the square root of 3 plus the square root of 6. And when you FOIL those together, you're going to be able to get rid of those radicals. So when you have 2 terms in the denominator, make sure, then you're going to multiply by the denominator's conjugate. That's J-U-G-A-T. Okay, and by multiplying the top and the bottom by it, you're just multiplying by 1 and you're not really changing the value. So let's go ahead and do this. We're going to take, and when you do the conjugate, you're going to find out that when you multiply that, all you're really going to do of the FOIL process is the F and the L, because these will cancel out. Okay, first times first, 3 times 3, you got a pair of 3's that'll come out, so you have 3. And then if on this one, you're going to have a positive square root of 18, and here you're going to have a negative square root of 18. So those will in fact cancel, which leaves you with just negative times positive, which is negative, and then you have a pair of 6's. Since your index is 2, a 6 will come out. So this one, when you do the top, it is important, don't distribute, just go ahead and leave these factored. So we're going to have -3 and then plus those. Because when you simplify these, 3 minus 6 is -3. You're going to find that we can cancel those two, and our answer is in fact just that. Square root of 3 plus the square root of 6 is our answer for this one. Okay. Let's try another one. We've got 3 over -5 minus the square root of 6. So we want to multiply this by the conjugate of the bottom. So we're going to have -5 plus the square root of 6 times -5 plus the square root of 6. So first times first gives us, we're going to leave the top factored. Negative times negative is a positive. 5 times 5 is 25. And then we're going to go ahead, the inside and outside terms are going to cancel, so we're going to do the last times last. Negative times positive is negative, and then we have a pair of 6's, so a 6 comes out. And 25 minus 6 is 19, so our answer is 3 times -5 plus the square root of 6, all over 19. And that's our answer. Okay. Let's try another one. Negative 2 divided by negative square root of 3 plus the square root of 5. So, in order to rationalize this, we're going to multiply it by its conjugate. So we got negative square root of 3 minus the square root of 5 over negative 3. Notice we didn't change this one. This is the sign we're changing to get the conjugate. Okay, so now we're going to leave the top factored. Oh, I kind of messed that up, didn't I? Okay, negative times negative is positive, and then we have a pair of 3's that bring a 3 out. And then last times last, negative, positive times negative is negative, and then we have a pair of 5's that bring out a 5. So when you look at this, 3 minus 5 is a negative 2. Our negative 2's will cancel, leaving us with negative square root of 3 minus the square root of 5 as our answer. Okay, here we have 243z cubed over the cubed of 9c. Okay, since we're looking at these and we do have the indexes are the same, we could combine these into one fraction. And can we cancel? And we could. These will cancel. And will 9 go into 243? Yes, it will. In fact, it goes, we have, it's 27. 243 divided by 9 is, in fact, 27. So we end up with having, because that canceled, that leaving us with 27 inside, we have the cube root of 27, and the cube root of 27 is 3, because 3 times 3 times 3 is 27. So our answer for that one is 3. We've got negative 8 over 3x. Okay, and if you notice, we have, and the radical has both of those, we don't have two terms in this one, so we can't multiply it by its conjugate. So this one, we would be doing what we learned last time, is rationalizing the denominator. So we have to take the top and the bottom, times it. Now on the top, be careful, it's not negative 8 times 3. You have to do the outsides times outside. So we have a negative 8 square root of 3x on the top. And the bottom, since we have both of those multiplying each other, they're a pair, so they come out. And since these both on the outside, there's nothing there that can cancel, this is our answer. Just doing these, getting the practice, the easier they get as you do them. Okay, let's do this one. We've got the square root of 90 over the square root of 55. Since they're both the square root, we could write it like this if we wanted to. Do they have anything in common that we can get rid of? Yes, they do. They both have a 5. You can divide each of them by 5. And this would give us square root of 18 over the square root of 11. Of course, I broke these up again because I know that with a fraction inside a radical, we're going to have a radical on the top and a radical on the bottom. Now we're going to have to rationalize this to get rid of the radical on the bottom. So we multiply it by the square root of 11, and that gives us the answer of, well, if we have 18 times 11, we know that 2 goes into this 9 times, and 3 times 3. So we've got a pair of 3's that come out for the top. And inside we have 2 and 11, which gives us the square root of 22. And then square root of 11 times square root of 11 is 11. And that is as far as we can go because we can't cancel in here because one's inside, one's outside. Really important to remember that you can only cancel if they're on the same side of the fence. And that fence is the radical sign. All right, let's do another one. We have 14. We want to take the cube root of it, and we're going to divide it by the cube root of 18. Do these, since the indexes are the same, we can divide, and they're both inside the radicals, we can reduce as much as we can. So let's take out a 2 from both sides, from the top and the bottom, which gives us the cube root of 7 over the cube root of 9. Now again, we could take this and take it times 9, or you can identify that we've got a 3 times 3 here. So all we really have to do is multiply it by square root of 3. This will give us a 3 on the bottom, and then they don't have anything in common because the factors of 7 are 1 and 7. So that would just be 21, the cube root of 21, over 3. And that's our answer. Again, if you wanted to, and if you forget that you can break that down, you could multiply it by the cube root of 9. You could have done that twice in order to get 3 of them. But you still would have ended up with, because you have 81, you still would have been able to pull a 3 out because we've got 3 times 3 times 3 times 3. So we've got a 3 that comes out and a 3 inside. So 3 times 7 is 21. And again, as you can see, they're both the same answers. So you're not in trouble if you forget to break these down. I find that breaking these down makes it a whole lot simpler, and you don't have to deal with larger numbers that way. Okay, let's see what we've got. Oh, let's go back and let's try to do some more. So we have this one. Since there's 2 terms in the bottom, you have to do the conjugate to get rid of, to rationalize it. So the first number stays the same, but we take the sign of the different one. So leave the top terms factored, and then we're going to do the full without the I and the O on the bottom. So square root of 3 times square root of 3 is 3. Then positive times negative is negative. And then square root of 6 times square root of 6 is 6. You simplify that, gives you negative 3, and you'll find that those will cancel. It leaves you with square root of 6, and that it would be the answer on that one. Let's do let's do this one. Okay, we need a conjugate of this one as well. So we have to multiply the first one, the sign stays the same, but we change the sign on the second one. Leave the top factored. And we're going to do the full on this one because the O and the I will cancel. 9 times 9 is 81. And then we have a negative here because negative times positive is negative. And then the 2's inside will pull out just 1 2. So 71 minus 2, or 81 minus 2 is 79. So our answer for this one is, and you can leave a factor, you don't have to distribute the top. Is that? And that, just remember, if there's one term, you just rationalize, and if there's 2 terms, you have to use the conjugate.